Welcome everybody to session 2 a.m. Just going to give it another couple of minutes for people to join.
Bless you.
Yeah, let's hope it doesn't happen while I'm trying to speak.
Minutes past. Welcome everyone to session 2 a.m. introducing DevOps, CICD and automated test. And your hosts today are Ralph and Hans from BMC Software. So I'll turn it over to you guys. Have a good one.
Okay.
Thank you, Stuart.
Thank you. Thank you and welcome. My name is Hans Stern. I'm a technical account manager with BMC Software. With me today, I have Ralph Nuss, who is a technical solution engineer, also with BMC Software. He has great experience in implementing DevOps and supporting ways of working with our clients. Together, we will attempt to give you a glimpse of some ways that have been working in making the mainframe platform as feasible and easy to work with as any platform. So let me start by asking you, as a mainframe developer and systems analyst, would doubling your efficiency and making your everyday work easier be of interest to you? If so, you've come to the right room. But first of all, I'd like to draw your attention to the GSE UK 2021 charity raffle. Feel free to follow the link or scan the QR code to donate and help Royal National Lifeboat Institution and Guide Dogs for the Blind. So, starting off, there's a land called Beginning Again, where the sky is always blue and where broken dreams are fixed. This is not the world we live in. As mainframers, we have systems that are very large, complex, and full of undiscovered gems and nightmares. We cannot always rewrite those systems, but we can learn to be smarter when working with them. We at BMC are focused on collaborating with organizations around improving developer experience and software delivery cycles. Modern graphical interfaces, powerful analysis capabilities, automation in testing and deployment processes, enabling parallel delivery streams and reducing time to deliver. All these add up to a significant game changer for mainframe teams. When we start building new stuff in a virtual world, we are blessed. We start from scratch and we're free to let our minds flow and design freely. However, how often does that happen? Often we need to maintain or create similar services of what already exists, just with a new twitch. And if you are an existing business running on a mainframe, you will run into changing these systems often rather than building completely from scratch. However, a Forrester research shows that the mainframe remains the system of record server, and you will run into changing programs on the mainframe if you're working with new business initiatives. Oh, mainframe is so yesterday and legacy, you say. Now hold on a minute. What if the mainframe was just another platform where you, as a DevOps and agile developer, can develop and maintain at the same speed and quality as your colleagues in distributed systems? What if you were an all-round systems analyst and developer? In a data-driven world, we need to understand how data resides at rest and how data is being created, transformed, stored, consumed, and finally laid to rest or archived. We need to understand the full life cycle of data and processes around the information we're capturing and enriching. How often do you get to maintain other people's codes? And what does it take to understand it? Reading through millions of lines of code may be one way. However, it is very time-consuming and might not be the most efficient way. So are there other ways of doing this? Let us investigate some ways that we have seen work, implementing DevOps on the mainframe. That is really mainstreaming the mainframe. We all know the monoliths of this world. Breaking these down to consumable, maintainable pieces of code makes the world so much easier. However, in these times of supporting the business, we are rarely given the chance to do it again for the sake of nice design. Rather, we will need to find new ways of working. So let us begin with showing you what we did at BMC CompuWare. And I will not kid you, it does take some effort. We were definitely not on the forefront of ways of working. In real time, we spent more than 60% of our development efforts on fixing problems and only less than 40% on innovation. We had a standard waterfall way of working, initiating code change, analyze what needed to be done, scope the testing, create environments, prepare data, etc. All in all, time-consuming efforts. We thought we could do it better and started a value stream mapping exercise. Where is the time spent and where is the value created in the process? By the way, should you be interested in doing so, please let us know. We will be glad to help you conducting such an exercise. As you can see, the processes were very separate and perhaps even executed by separate organizational departments. So time is wasted and money between the processes waiting for the next step. So we investigated if something could be done. We first looked at each step. We first looked at making each step more efficient. For this, we needed new ways of working, improving how we approach each step, i.e. automating. However, now there were more time between each step, so we were spending less time in each step. So now we minimized the time wasted between each step by making sure that the next step were triggered immediately after, or at least starting earlier. If we could, steps we could merge or combine, we would do this for even further and greater efficiency. So remember where we came from. Less than 40% developer effort spent on innovation and mean time to repair was more than 70 days. In 5 years, using this process, moving into a DevOps approach, we went from spending less than 40% of our time on innovation to nearly 90% of our time, while at the same time while reducing mean time to repair to close to 20 days rather than that of 2.5 months. Did I, by the way, mention that our full development process also became more agile? So these are really the numbers. We more than doubled our developer productivity. We increased developer effectiveness tenfold, and we identified 25% more defects even earlier in the process. Thus, we decreased the number of escape defects. We've seen similar pains other places. We were definitely not alone. They fixed this pain, and by fixing this pain, this bank now have a platform. Now have a platform on the mainframe, which is at level or better than that of other platforms when it comes to innovation and development. So this is, I would like to, by the way, refer you to that there is a lunch and learn session on the 11th of November at 1 p.m. GMT, where several banks will be going through what they did. So feel free to join there. So now let us go into a little more detail on solutions and ways of working that may even help you. So let's go on a journey. This is a very typical task for a developer. It's a business change. Now the business comes back to us and asks us to help them change the underlying software to facilitate this new requirements. Okay. What we've seen already is that we've shown that this commission calculation that we're being asked to change is done in the job CWX TJCLC, which in effect runs the program CWX TCOB. We're being asked to facilitate a salesperson achieving revenue of between 100,000 euros and 500,000 euros will be granted commission of 15%. So Ralph, as a developer, how would you go about this?
Yeah, thank you, Hans, for laying this foundation and giving me this task. So you mentioned, or yeah, the slide mentioned already the first most important step that we need to take. We need to analyze the situation, and I, as a developer, I need to ask and answer questions like, which programs do I need to modify? How do I need to modify those programs? And if I modify any program, does that affect any of my other programs? So if I'm an expert developer knowing everything about my application, the task may be as easy as simply taking a look at the source code, using my editor commands that I'm familiar with to very quickly, for example, find out that we are executing these subprograms based on the CWXT program that we have identified.
So Ralph, what if you're not an expert of the application, if you're new to it? Or what if you're new to the whole mainframe? What would you do then?
Yeah, that's a very important thing to consider, especially nowadays that more and more non-mainframe people are asked to join the mainframe teams. And many teams have addressed, especially this second issue, by moving away or by providing Eclipse-based graphical user interfaces and the appropriate editors, which makes using the editor and looking at the code more intuitive for those non-mainframe people. But the problem still remains that if I don't know enough about the application, or if the application becomes more complex, that we need support of other tools. So we need to have some tools that are able to analyze the code for us in an automated fashion and store these results in a database and allow us to report on the database. So here, for example, we have the result of such a report, which was created in a source code management tool against the repository. And this report tells me that based on my main program, all the other components that are affected or are in relationship to this one program are listed here. So I know which components I need to consider in my further analysis. And sometimes people are more visual, so they understand graphics more, and graphics help them to understand relationships better. So this is an alternative display of the same information using the same tool, but a different interface. And if the graphics become too complex, if there are too many objects to be considered, I could use this table exported to other tools, in the simplest case to Excel, and be able to drill down and filter down into the things that are important for me, and filter out those things that are less important for me for my analysis. So ultimately, working will be somewhere in this continuum of different levels of using tool support. So on the one hand, there is using the editor and doing many things manually, whereas on the other hand, there is this full tool support. In my experience, the truth lies somewhere in between. So to a certain degree, these tools will help me to avoid spending time on analyzing code of programs that I don't need to analyze to fix my specific problem. But on the other hand, once I have identified the right components, I then will have to be able to take a look at the code itself and understand what's going on in a detailed level. So getting to our example, it's the same story. So that will be a repeating pattern. We have different degrees of tool support that we can use. So in the worst case, finding out how the commission is calculated and where it's being calculated would be down to using the editor. More sophisticated tools would allow me to not only find those locations where we find the name of our variable, but also how the variable is being used. So I would be probably interested in where is it modified, meaning where is it being calculated. The problem with this approach very often is that I need to know my tool very well. I need to know which command is doing the right work for me. So again, code analysis tools can come into play, and they can do the scan and this analysis over several levels of hierarchy and interactions between different fields for me, which at one point means that we get so much information that we get overwhelmed. And again, being able to filter down the information to what's important to me is then a very important aspect of these more graphical interfaces. So here, for example, based on my commission field, I see not only where data flows into my commission field, but also I see very many fields that get modified by my commission. But that's not what I'm interested in right now. I'm interested in finding out where is my field being calculated. And once I filter down by these locations, I very quickly see this seems to be the initialization. And here I identify a program that seems to be modifying my commission.
So let me understand this correct. Are all these methods using static code analysis? What does that do at runtime? What happens at runtime? Couldn't the application behave completely different at runtime?
That's a very important and very good point. Yeah, so even though most of these, so you're right, it's static code analysis. So we're looking at the source code, even with those tools. But you're right, it's not always easy to determine what's going on at execution time. So you will have to be able to figure out that as well. And to find out what's going on in your program at execution time, as soon as you find yourself as a developer, find yourself modifying the code to get more information about the behavior of your program, you should immediately stop and start thinking about using your debugger. So this is what I'm using here in the middle, telling my debugger to, for example, trace program execution or trace on the program execution level, so that after I have run some test records that process salespeople in my case, because that's what I'm interested in. So once we have processed these records, I get this list of call or return statements, and I get a list of all the programs. The problem again is I need to know that my debugger provides this capability, and I need to know how to activate this capability. And then we get this list, and I need to be able to figure out how many programs are there. In fact, there are many repetitions of the same program. So compare this to this diagram and to this display over here. Generating the same plus more information in a more digestible form. So I immediately see that there are only 2 subprograms, but I also see that we accessed some data sets, and I would also see if we access DB2 tables or IMS databases, and also how we access them. Do we read? Do we update? What is it what we're doing? And to get all this wealth of information, all I had to do as the developer was simply check a box while I was debugging my program and running my test cases through my program. So this again, it gives me great insight by just clicking one mouse, and very quickly gives me insight into my application. And ultimately, I could also tell my debugger to stop execution whenever the commission gets modified. And again, this would give me at runtime the confirmation that it's indeed this subprogram is the only place at which the calculation will happen.
Okay. So that means you've identified the code, the program that needs changing. How do you then figure out how to change the code?
Yeah, so this is the point at which we need to take a closer look and really need to use the editor. In the best case, we get also some visual representation of how my code hangs together. This is a very simple example. It's as simple as it can get. So we immediately see there are only 2 main processes. Looking at the code, I immediately see, okay, one of them is being triggered if we process a sales record, which is the process sales paragraph. So here's where the calculation happens, where we calculate the commission. And looking at the code, I then figure out that we use a table of percentage values that we determine based on the range in which the sales amount falls. So this is how the calculation works. And the solution seems to be very straightforward and very simple in this case. I need to add an additional range based on the requirement between 100,000 and 1 to 500,000. I add a new percentage to my percentage values table, and then obviously I need to take care of the calculation down here and the logic in the calculation.
So now you know what to do. How do you go about applying that change?
Yeah, so I try to make a habit as a developer to, before I start coding and before I start really laying hands on my code, I tend to think about how can I validate that my changes actually implement the right requirements and don't break anything. So I try to design or at least think about my test cases before I start coding.
So thinking about testing and defining your new test cases before coding, that sounds a lot like test-driven development to me, doesn't it?
Yes, it does. At least it's inspired by test-driven development, and I try to follow this habit as much as possible. But for mainframe developers, it's not always that easy. So consider this task at hand. It's a subprogram that I need to be able to test. So there will be questions about how can I execute a subprogram without having the main program? And if my subprogram is a little bit more complicated, how can I make sure that the data that resides in my database is always in such a state that I can repeat my tests easily. And especially if my program is modifying that data, how can I work in such a situation? And also, maybe there are subprograms that I need to consider. What if I'm not responsible for the subprograms, but they need modification as well? How can I still test my program without having to wait for the subprograms being available? So what many developers around the world do, and I think what everyone on this call has done in their life already, is writing your own driver programs, feeding those programs with artificial input data, calling our subprogram, and then finding ways to determine if we returned the right output data in our tests. Very often, or sometimes, developers write their own mock programs, so artificial versions of subprograms. And when it comes to the data in the databases and datasets, very often it's down to going into your editor and modify your input data manually before you can execute your test. So that's very time consuming, and it's, yeah, we spend a lot of time setting up, especially the input data after we have repeated, after we've executed our tests, to be able to repeat our tests. So as an addition or an alternative, depending on the situation, other developers use their debugger and they modify the variables at runtime to get the data constellations that execute specific parts of their programs that they know need testing. This comes in very handy, for example, if you need to test your error handling routines, because it's not always very easy to create these error situations in a real life scenario. But the problem is it's still a manual effort. And many developers around the world using this method tell me that they struggle with documenting what they did and with repeating what they did in a consistent manner. So I have to take notes. Which field did I modify in which way? So that's always a challenge for if you're using this approach. And what I've seen, and I've been involved with at least one customer in Germany, is that they combined both ideas, so to speak. So they had created their own testing framework with their own common driver program and a set of mock programs. And to be able to get test data for these for this testing frameworks, they had the idea, why not execute my current version of the programs under the control of our debugger, write all the data that gets passed into my program to the log, and then also, if we call subprograms, write the data that we use to call and the return data to logs, so that we have all the data that we need to define a test in the log, then extract it to what they was using were CSV files in the past, and then they were able to feed that into their framework. So that was a very nice idea and approach.
Okay, so in creating these test cases, wouldn't it be cool if your debugger could create those test cases automatically for you while you were debugging your program?
So back in the days, that would have sounded like black magic almost. But it's funny that you say that, because this is what I did in my environment, in my case. So here I have used this method using my expediter to create a whole bunch of test cases that test my current version of the program for the different ranges that we have seen. And just to give you an example here, so we one test case, we pass a value of 85,000, whatever euro, I think we were using. And I know, or well, the current version of the program would calculate 10% of that. So this is my future assertion for this test case. So when we execute our program using this test case, we would always validate that we get a return value of 8,500. And the very first step that I usually do if I haven't touched the program and the test cases in a while is I use my current version of the tests, run them against the current version of my program, just to make sure that nothing broke in between. And also to get the confirmation that from this point onward, if anything fails in my tests, I know it was my doing, and I know it's up to me to repair anything, and it's not someone else's fault that might have kind of spoiled my testing. So here we see the result of the execution in a format that might be familiar to Java programmers. The green bar says, okay, still everything is okay. This is a format that's slightly different, using a different version of the tool. And both tell me, so tests are still working. And at the same time, I also can retrieve information about which parts of my code were executed on behalf of these test cases. So that's what the green highlighting is telling me here. And this gives me the confirmation that it's these test cases that I need to execute that part of the program that I am about to change. So I know these test cases are my basis, and these test cases are the ones that I need to extend for my further purposes.
So now you've made sure that your tests are testing the code you're going to change, and that the tests in their current version are executed successfully by your current version of the program. So what's next?
So next is I need to modify my existing test cases. So I take a look at what is it that I'm supposed to do, or what is it what my program is supposed to do. So I've got this new sales range, or this new sales amount range. This gives me some advice for potential test cases. And this is what I did here. I took my existing test cases, extended them by, in this case, 3 more cases. I always make a habit of using my boundary values, if there are boundary values, as input values and as test cases for sure. And then I take a value or a sample value somewhere in between. So I took 101,000, I took 500,000, and here in this case, I took 250,000. And if you take a look at what's already there, this allows me to validate that when I cross those boundary conditions from the lower range to the upper range, that the crossover happens in the way it's supposed to happen, and that I do not by accident confuse a less than sign probably with a less than or equal sign, which is something that can happen very quickly. And then on the other hand, I know the commission is 15% of the sales amount. Now, I'm not very good at doing calculations in my head, but I figured out that this would result in 37,500. So that's my new test case. And yeah, since I'm not very good at doing calculations in my head, I tend to use Excel spreadsheets to do these calculations, especially if they're a little bit more complex than just applying a percentage. And in the best case, I could use such an Excel spreadsheet actually to drive my tests in my testing tool, so that my testing tool would read this Excel sheet and take the input values and the expected output values as what it needs to validate against. So yeah.
So cool. That really, so you're actually using whatever is available. That's cool.
Well, yeah, I mean, why stick to one tool when there are so many tools out there, and whatever works for you should be applied. So next step for me is now that I take these new test cases and run them against the old version of my program following the TDD method. So test, fail, and then modify the code. So I need to fail first, and I confirm that it's only my new test cases that fail, but also that they do fail. So this is the expected result. If they did pass, that would only be by accident. So I would still have to take care of modifying my code.
Okay, so now you start coding?
Exactly. Now, finally, I start coding, which brings us back to the topic of using the editor. So we have talked about that many customers worldwide have started adopting graphical user interfaces and use the editors that come with those interfaces. Now, you won't convince any decent mainframe developer of using anything else than the ISPF editor if the new editor doesn't provide not only the same capabilities as the ISPF editor, so the least that they should provide is code highlighting based on the language that you're using, but they need to provide serious advantages. So what almost every editor in the world provides is a way of giving you an overview of the structure of your program, very often called outline. So I get a list of all my procedures, so paragraphs in the COBOL world. I get a list of all variables that have been defined. And then I can use this also as a navigation bar. So I click on any entry here and directly get to the point in my code at which this paragraph starts. So I don't have to scroll and scan through the code to find the right places. Also, what every editor provides is some type ahead or code completion functionality. So here I started typing and the editor suggests that I might want to add another value clause, which is a good guess here. In other cases, it may suggest variables that I have defined in my program already. And this all helps me to prevent making typing mistakes while I'm coding, which is one of the many causes, but typical causes of syntax errors while I'm coding. Beyond simple replacement or adding of words to the text, many editors also provide code snippets or templates, as some of them call it. So it's not about inserting one single word. It's more about inserting complete code constructs, like an if statement in this case. And you immediately see that this if statement looks completely different to what I was doing here. So it doesn't match my coding style. So this editor better be also possible or be capable of me modifying those code snippets to my needs or define my own code snippets and not only have a fixed set of code snippets or templates that I am bound to use and I can't modify to my needs. Anyway, at one point, hopefully I'm done with my coding.
So, Ralph, how did your name get in there?
Yeah, very good observation. So,
and also, what are the tiny marks on the sides?
Oh, yeah, good point. So my name got in there because I asked my editor to tag every line of code that I'm touching automatically with whatever I specified as what needs to be placed in either this comment area on the right-hand side or the comment area on the left-hand side. And this allows me to identify those lines of code that I've modified during my editing. That can come in very handy later on, as we'll see. And unfortunately, these tiny red marks, they are syntax error. So apparently, I have not always used the code completion, and lo and behold, suddenly there is a typo.
Okay, so that's not quite done yet, are you?
Yeah, that's right. So I need to take care of fixing these syntax errors, definitely. But the point is, I better make sure that I fix them now, because there's no sense of running this code through the compiler. I know it's going to fail anyway, so why waste time and CPU time by trying to compile something that I know that doesn't compile? So I can definitely will fix those syntax errors before. And once I've done that, what's remaining are these tiny blue marks you may have noticed as well. So this is not my editor doing some work. This is an add-on that we use in our site called SonarLint, which is a freeware open source tool, so to speak, which allows applying rules against all kinds of languages, including COBOL, which do not check for syntax errors, but which check for violations against coding standards and in-house coding rules. So SonarLint comes with a set of predefined rules which you can extend to your own needs. So as a developer, I don't have to have the book of instructions always with me, checking which coding rule may I have violated. SonarLint is telling me that immediately.
Okay. So what does this specific message tell you?
So here we see that the S range 6, which is my new 88 level that I defined for defining or used for defining my ranges, has not been used at all. So in this case, taking a look at the code and trying to understand what's going on here, this means I'm nowhere checking for it, which means actually what I'm doing is I check if my sales amount is in range 1, 2, 3, 4, or 5. And if it's neither of those, I assume it's in range 6. This might be a potential problem, because what if there is a sales amount that doesn't lie in any of my 6 ranges above 500,000? No one has specified what I should do here, but I shouldn't just work on assumptions. So I probably need to go back to the customer and ask them what should happen in this case. And then ultimately, I would also fix this situation.
See, that happens very often when you start analyzing stuff, suddenly new questions turn up.
Well, actually, I should have spotted this already when I designed my test cases, because going beyond, I told you, I check the boundaries. I should have checked what's going on beyond my highest boundary.
Yeah, but it's still, I mean, people don't very often, a business analyst will not consider what everything that happens.
Yeah, exactly. Exactly.
Great way of finding that. But that means once you're done now, you run your test set again.
Well, obviously, I run my test set again now that I think I'm done coding. So this was the old result. We failed with the old version of my program. Hopefully, maybe after some iterations. But the point with this tool is I can run very frequent iterations of those tests. At one point, hopefully, all my tests pass. Just giving you the 2 versions of the report, one more appealing to Java programmers, one more appealing to me. And at the same time, again, I look at the results of my test coverage and looking at my marking. This is where my marking, my tagging comes in handy. I can see that, yes, also these lines are green. So I made sure that really I test my changes. Although you might argue that, well, this was a simple change. What if there is more complex changes and my changes are all over the program? How do I verify? And this is what I did here. I asked this tool to look for these tags and treat those lines of code as specifically important. So this is what this critical verb is telling me here. And interpreting the results in this example means that of all my modified code, I executed 100% by my test. And that is the least I should aim for. Whereas the other parts of the code that I didn't touch may not be that important to me at this moment.
Okay, so that means you've successfully executed your tests and shown that all of the modified code have been executed with success. Now what? What would the next step?
So next step definitely at one point will be trying to bring my code into production. Well, obviously, that's not a one-step process. Usually there are different stages in such a process. So we have stages in which we develop, we have a testing stage, we have a pre-production stage and we have a production stage. So that is typical in every mainframe environment. I don't think there is any shop who is not doing this in some way or shape. What's interesting maybe in this situation is that if we take a look at these boxes, the orange one is telling me this is the version that I'm working on. The gray one is telling me this is another version, the production version. That's fair enough. There should probably be a production version if I'm modifying existing programs. But what we see here in this gray box is that there is another developer who is at the same time as me working at the same program and creating a separate version. So seeing this now allows me to reach out to this developer before any one of us is moving their code ahead and runs into maybe merging issues later on. So I can reach out to this developer and talk to them, and we can make sure that we align our changes even before we hand on our changes to the QA team. But at one time, it's time to in our case, we call it promote our code, which is simply saying, take all the code that I'm currently working on and move it to the next level so that now the test people know that I think I'm done with my work and they can take over.
Okay. So, yeah.
So there may be the issue that not every developer, well, sometimes you just miss something in your testing, in your coding. Like I missed the upper bound. So to make sure that this code that I'm promoting is up to speed and up to its purpose, we also make a habit of, once I'm promoting code, in our example, we trigger an automated build process, in this case, using Jenkins as our automation tool, which not only uses my tests, but all tests that may be lying around and runs them against all the components that I've promoted to the next level. And then we pass the test results together with some additional information to a tool called SonarQube, which is the big brother of SonarLint, and which understands all the information. So it's not looking at the code, but at test results, at code coverage, and other matrices. And it allows us to define quality gates, which trigger automated actions if something goes wrong. So in this case, the gate failed because some tests seem to have been failing. And the activities that we trigger in our case is that we take all the code that I've promoted and regress it back to the development level and send out an email to me as the developer informing me, oh, by the way, Ralph, there's more work to be done. So you better get back to the desk.
Okay. So remember where we came from? Okay. With mean time to repair 74 days and less than 40% innovation.
That was the CompuWare development teams, wasn't it? Yeah, I remember those times.
Yeah. Okay, so where did we go after 5 years? Well, as I said before, we did more than double the developer productivity. We increased their effectiveness tenfold. We found defects earlier and identified them, so that made sure that there were lesser escape defects. So
that was the success that you had at BMC, well, at CompuWare at that time. I remember those times, like I said. May I ask you a question in return to the questions that you were asking? How did these teams figure out these improvement values? So how did they figure out that they increased their productivity or the effectiveness by a factor of 10?
Well, we had to figure out how to baseline what we did. Okay.
Okay. Yeah. Got you.
So we now have a solution to measure the usage of our functions and timings using SMF records. So that means going forward, we continuously measure our progress and change the way we work to improve quality, speed, and efficiency. And by the way, everybody here, we also deliver these solutions to our clients as part of our service, so you too can measure your progress. So all in all, I hope we've shown you that the mainframe can be as agile and easy to work on platform as we all dream about. So thank you very much. Feel free to contact us if you have any questions or further interest in what we did and can do for you. And again, thank you for spending time with us. We know how precious time is. We hope you will take an additional 5 minutes to fill in the survey. Thanks, and hope to see you soon.
Thank you, Hans. And thank you, everyone, also from my side.
Stuart, if you want to say something about this.
Yeah, thanks, Hans. Thanks, Ralph. Does anyone have any questions? You can type them in the chat. I can unmute you if you wanted to ask it in person.
Okay,
Yep.
Not a question, but a nice comment.
Yeah.
Thank you, Atul.
Thank you.
Anyway, feel free to ask questions. This is what we're here for. We're not here for taking any praise.
We take that as well.
Yeah.
Well, if there's nothing else, why not? Yeah.
Every presenter deserves a little bit of praise for getting stuff done. No, okay. Well, thank you very much. Just remember, this was 2 AM for feedback. And thank you again, Ralph. Thank you, Hans. And to everyone else, have a great GSE. Thank you.
Thank you,
Bye-bye.
Thank you, Stuart, for having us. Bye.
No problem. Bye.
Bye-bye.